All right, hopefully I can get this to work. So we are going to be on our last kind of section of physical science. So I'm just going to label this one physics. So the next available blank page in your notebook, just go ahead and fold it. If you're like me, I don't have a whole lot of pages left in my notebook. If you've been in my class all year, you probably don't have a whole lot left, and that's fine. But physics, well, today's date is 4:30. Oh, wait, no, it's not. I'm sorry, it's 29. No, it's 4:29. And our essential question for this first part of physics is pretty much how is motion determined? Okay. So we're going to be talking about motion pretty much for the first part. We're going to go a little bit into Newton's laws of physics, so the first, second, and third. And then I think we're going to end with energy. So your NCFE, I think, is June 8th. So that will take us, yeah, we'll probably be working all the way up until June 8th. Well, no, we won't, because you have your math and whatever. So yeah, they're EOGs and NCFEs. So physics, that is the first part. So go ahead and flip it over to the next available page. This is going to be your graphic organizer. So I'm just going to label it graphic organizer. And today's date of April 29th. I can't believe it's almost May. My goodness. Yeah, so I guess I'll probably do it sideways. Yeah. And it's going to be kind of a graph of sorts. And this is something that the North Carolina Standards of Education says that you need to be aware of is this graph of motion. Do I have a ruler available? Probably not, because I always grow legs and walk off and go somewhere. Let me grab a ruler real quick. And it should take up, I don't know, maybe about half the page or so for you to get this done. Ugh, stop wrinkling. Because I'm probably going to have some information over on the other side. So this will be about 3 different line graphs that you're going to have all together. So it should only take up half the page, because we're going to be writing information over here. And kind of, I guess, draw like a little arrow down here. Okay. So that's what it should look like. And at different points, I am going to be covering this up because some kids like to just skip ahead. And you get to miss out on my fun talking. Oh, wait, that's the answer key. I don't want to flip that over. I only flip this over here. So along the bottom, I'm going to zoom in a little bit more. Along the bottom, do I have a regular pen? Yes, I do. We're going to put time. Okay. So this is showing that time as time is going by. So if you're here, kind of think of this as 0.0. And this is whatever time. It could be an hour, it could be whatever. Each little increment could be, I'm going to make little increments. Each little increment could be 10 minutes, could be 5 minutes, could be 10 seconds for all we know. The time in this case is irrelevant. When you get to graph questions on your NCFE, which pretty much your NCFE is going to be, can you interpret different graphs, different charts? So as long as you can read it and kind of ascertain the information that it's asking you, you should be fine. Or at least use some of your process of elimination questions. Like there's supposed to be like 4 questions on like volvoxes and amoebas and all that wonderful stuff. So you're like, oh bleep, Miss Penny, I don't remember it. It's okay. So that's the bottom side. Now let me flip over to this side, so our y-axis, y to the sky, and I'm just going to kind of make up these little increments. Alright, because I don't have graph paper. And this one is actually going to be an arrow as well. Just made this one a little too tall. But this, oops, I put a little arrow at the top, so you can see, and I guess I'll keep doing my little increments all the way up. They're supposed to be my space, but for purposes of time, yada, 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 I'm just going to flip through. And this is actually going to be distance. Okay, so this is distance. I think I wrote it in blue pen the other time. Of course, it's not focusing right. Why would it? See if it'll focus now. So distance. So as you are going up. This could be 5 meters, 10 meters, however you want to kind of think of it as. So that is where we're going to start off with. We're actually going to start off at our 0, 0 point. And there's our little graph part right there. You will need a little bit of, I don't know, ability to kind of do things. So I guess what we want to do is, I'm going to use 3 different colors just because it's going to make more sense for me. The first one I'm going to do, I'll do it purple, is going to be kind of a, I guess a straight line, kind of angled up. I'm going to pick this up a little bit more, zoom it up just a little bit. Your points all need to start at that 0, 0 mark. Okay, where time and distance are all at 0. So this is pretty much the starting point is right down here. It's going to go up pretty fast. So, whoopsies. Let me see this. Okay, so that's going to be my first line. That's pretty easy. The second line, I guess I'll do a different color. Again, it's going to start off down here, and it's going to, I'm going to use my little ruler, go like that, and then it's going to flatten out. It's probably not going to be straight. This should be a straight line. And then it's going to come right back down again. And it doesn't really matter if it's on a perfect increment line or not. So that's what the second one should look like. Okay. What color is the version purple? And then the third one is going to be an upward sloping curve. Okay. I think whatever. So that is what yours should look like. So you have an upward sloping curve is that one. Oh boy, I might have messed that one up. This should just all be the same kind of point. So let's take a little bit of white out. Kind of cover that up a little bit. There should not be a weird little line like that. So to describe the purple one, okay, so we have our purple one, which is the first one that we did. This is kind of a straight up line, I should say. Oh my flipping goodness. Come on. Why are you not working today? Because it's Monday. Oh, you haven't been here. All right. So this is pretty much just going to be fast, steady speed. So they're going, this purple line is showing it's going a very great distance in a short amount of time. So you can imagine this as, let me put units over here. We'll put this as 0 kilometers. Oops, you can't see that. You put that as 0 kilometers. Let's say 5, and we'll put this in kms. So I'll put it in kilometers the entire time. It'll be meters. 5 kilometers, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So this is very, very fast, steady speed. So you can kind of think of this maybe as like a jet taking off. It's going to stay at a pretty constant speed, but it's going very, very fast. So it's going to cover, and let's say this is, that's a pretty big distance, what I just did there. We'll do this time in minutes. I put 2 minutes down there. Time in minutes. We'll just do this 10, 20, oops, this would be 30, must be 40, etc., etc. I'm not going to do that. But you can see that this line is going about in 30 minutes, about 55. So it's going to go about 55 kilometers in 30 minutes based on where my little makeshift graph is. And that's pretty decent, 55 kilometers, whatever. So it's going at a same kind of speed. So you could do a projection of where do you think it's going to be at based on where the line is at. This is a fast, steady speed. So think about something just accelerating at a pretty even pace. It's going at the same rate. There's not a bunch of bumps and lines or anything else. So fast, steady speed. Now for this, I guess we'll do the little curved line first. So this one's a little bit different. We're looking at our curved line. And of course, it can't handle when I move things around, apparently. Come on. Oh man, that looks really sloppy down there, but whatever. This means it's getting faster. Okay? So it is accelerating. Okay? Its acceleration rate is increasing. So it's kind of starting off, it's going, but then it's getting faster because it's going up at a faster rate. It's a much greater curve. So if it was just if it was a steady stream, it would be a straight line. But since it's kind of curving, it's getting faster. It's accelerating. It's changing its speed. It's increasing its speed. Okay? And I'll add a little bit more information to that a little bit. So looking at our blue one now, our last little one, our little half of a hexagon, I guess. This is a steady speed right here. Right? It's increasing its speed. It's going at the same rate. But once it's up here, it's stationary. Okay? It is not moving. It is staying in the same point. So however many minutes that is. What are we at? Oh, no, wait, this is kilometers. So once it maybe reaches 12 kilometers, it's going to just pause. So increase to a certain point, and then as time goes by, so it's going to sit at this spot. So it's 50, 60, 70, 80, 90, 100, 110, 120, 130. So it's actually going to stay at this spot from 30 minutes to about 115. So it's not moving for a good amount of time. So the distance is not changing, but time is still going on. Okay. So this person, let's say it's in a car or they're in a boat, whatever it is, they got to a certain point and then they stopped. And then for that time, from 30 minutes to 115, let's say, it's just sitting there. So maybe they're having lunch, the vehicle, whatever it is not moving. Okay? And then this part down here is going to be returning to start. So they're actually just kind of they left, maybe they went to a restaurant, they're parked their car, they're waiting, and now they're heading back home because their distance is going right back to where it was. Now, if it was going up, if it was an increasing line, they're continuing on. They're not going back to start. They're going someplace different because of their distance. But in this case, they went to a certain point, they stayed, so the vehicle was not moving, and then they started returning. And my graph probably isn't exactly the same because this should be, let's say it took them 30 minutes. It should be a little bit further out. Okay. However, because this is not something completely precise, I'm not too worried about. So that is what your graph should look like. Now over on the side, I told you to leave some space over there. Of course, this thing's being a boob. Colors don't want to use. So this is pretty much just showing a graph of motion. That's all that this is. It's a graph of motion. So I'm going to put that down here. So it's a graph. It's like wonkies. It's a graph of motion. And you will probably see something like this on your NCFE. So I don't want you to be like, oh my gosh, even if you don't really remember what it all means, you should be able to interpret it. And I know that if I see something at least once, I have some sort of familiarity with it. So it is a distance, and you might see this as a distance / time, or a position / time graph. So you could see them written as either thing, but that's kind of what they're called. So I'm going to skip that, cover that back up. So I'm still looking at this. So there's going to be kind of 4 different things that you might see on the graph and just being able to understand what they are. The first kind of thing you might see is a flat line. Flat line means that there is no motion. It has stopped. And this could be a person running. It could be a boat, a train, a car, anything that's in motion. We could be talking about an asteroid hitting Earth. Once it flatlines, it's stopped. The second thing that you could see on a motion or distance / time or position / time graph is that a line is sloping, meaning it's not a straight line, but sloping up. And that just means that it is a constant speed away from starting point. So that little 0, 0. Okay. So sloping upward is just a constant speed away from the start. Okay. Next one. Sloping downward. Okay, so we're kind of... sloping downward is going to be a constant speed back, oops, that's an R, towards the start. Okay, so it's sloping downward, it's a constant speed back towards the start. Okay, and then the last thing, numero quattro, a curved line. Looking at this. Okay, so let's put curved line. All right, I'm just gonna write it. Changing speed. Which equals acceleration. Okay, so curved line, it's changing speed. It is accelerating. But anytime you see a line that's going upwards on the graph is going to be the constant speed away. If it's sloping downwards back to the 0, 0 point on your graph, or 0 distance on your graph, it's just going back to the beginning. All right, ta-da!